Good day and welcome participants to our online training for data handling and management using free and open source software and other geospatial technologies for Sentinel-2 for agriculture. Once again, I am Brent Palercuna from Environmental Science for Social Change, your lecturer for today. So now we are on the 10th part of our online training about the introductory videos on Sen2Agri and the training data gaps. On this 10th part, we have two parts or two videos which introduces the Sen2Agri and the relationship between the gaps of the training data with the Sen2Agri. Now I will go with the introduction to Sentinel-2 for agriculture. So here's my presentation outline. It has three parts, a quick introduction and a hands-on demonstration and some useful commands. I'll be discussing what is a Sentinel-2 for agriculture, its intended users, two ways on how to use it. For the second part, I'll be discussing the web interface, showing how to use the web interface, creating site and specifying the products, how to run the custom jobs, and some details about the input shapefile, and some useful commands. And for letter C of part 3, I'll show you some outputs that are generated by Sen2Agri using the training data we gathered from the field. So most of the parts for part 3, letter A and B, will be skipped since these are intended for much advanced users. Now, Sen2Agri is a operational system which is a standalone processing chain that generates a set of products for agriculture monitoring from Sentinel-2 and Landsat 8 time series. So, Sentinel-2 for agriculture, or Sen2Agri for short, is a system or software that was funded by European Space Agency to use the satellite-derived data from Sentinel-2 and Landsat 8. So as we all know, Landsat 8 and Sentinel-2 are moderate to high-resolution spatial data derived from satellite. So Sentinel-2 has a resolution of 10 meter by 10 meter, while Landsat has a resolution of 30 meter by 30 meter. So it combines the high resolution and high temporal characteristics of both remote sensing products. So the main products of Sentinel-2 for agriculture are the following: the atmospherically corrected images, or the L2A, the cloud-free surface reflectance composites, or the L3A, biophysical indicators, or the L3B, namely the NDVI, or the normalized difference vegetation index, and the leaf area index, dynamic cropland mask, or the L4A, and the crop type or the L4D. The L in this naming convention means level. So as the product has a higher numerical value for its L, it means that some processing or some basic post-processing have already been done to produce such product. So as we go along from L2A to L4D, it means that most of the processing have been done. So in short, L2A serve as the product or input for us to produce the higher level products such as L3A, L3B, L4B, and L4A. So the intended users of Sen2Agri are the following: the decision makers or the high-level analysts, specifically the agricultural officers coming from different local government units, the operator level users. So these are the users that run Sen2Agri to their own system and disseminates them eventually to their supervisors or the decision makers or high-level analysts. For the third part, I assume mostly that few participants came from this group. So these groups comprise of the academe, the research and training organizations, and other non-profit organizations. Example is us, ESSC, Environmental Science for Social Change. So most of you, I think, I assume, fall on this category. So there are two ways of using the system. We have an automated mode, which requires the full system installation, and the manual mode. So it only includes the main processors or the major processors from Orfeo Toolbox, a free remote sensing software, and Sentinel application or SNAP, which is also funded by the